All our science, compared to reality, is primitive and childishly naive, and yet it is the most valuable thing we have. Albert Einstein. The Earth plays a unique role in breaking the symmetry of the universe. In elementary particle physics, there is a concept of SR violation, violation of charge, C, and spatial, P, parity. It is known that matter prevails over antimatter only because a small violation of SR symmetry occurred in the early universe. However, it was on Earth that this violation manifested itself on a macroscopic scale, in the form of asymmetry of left and right molecules inherent in all living organisms. Why this happened exactly on our planet is not clear to the end. Perhaps a unique combination of physical conditions and chemical processes led to the strengthening of the original SR asymmetry. Besides, the very existence of life and mind introduces a new element of symmetry breaking in the universe. After all, the mind is directed to cognition of laws of nature and can use them for its own purposes. This qualitatively changes the symmetry of the relationship between the observer and the environment. Thus, the Earth really plays a unique role of the main symmetry breaker in the scales of the observed universe. But is it possible that somewhere else in another corner of the cosmos there are similar oases of asymmetry generated by other forms of life and mind? This question remains open for now. Do you think, can there be other islands of violation of universal symmetries in our universe? Or is the Earth still a unique exception to the general rules? Man is the measure of all things, Protagoras. This idea of the relationship between the observer and the observed resonates with the concept of symmetry breaking by the mind. Let's imagine that we have two identical screw factories. They produce left and right screws in equal quantities, so that the total number of left and right screws coincides. This is the manifestation of the original symmetry. But suddenly at one of the factories, there is a breakdown of equipment, because of which it begins to produce slightly more left screws than right screws. Thus, the symmetry is broken. At the output, we get not 50% by 50%, but, say, 52% of left screws against 48% of right ones. This is the analog of SR violation in the language of ordinary things. A small defect in the operation of one factory broke the original symmetry of production. The same thing happened in the universe. A small defect in weak particle interactions caused the predominance of matter over antimatter. An important consequence of the SR violation was the explanation of the predominance of matter over antimatter in the observed universe. According to the Sakata-Offman theory, a small SR asymmetry in the early stages of the Big Bang led to the predominant accumulation of matter. Thus, the discovery of microscopic SR violation allowed us to explain one of the fundamental mysteries about the macroscopic asymmetry of our world. Here again, we return to the unique role of the Earth in reinforcing this initial asymmetry. How exactly does symmetry breaking manifest itself on our planet Earth? First, we are talking about the violation of mirror symmetry of organic molecules, which leads to their chirality. Practically all biological molecules, including amino acids, sugars, nucleic acids, are asymmetric or left-handed structures. Second, this symmetry breaking affects fundamental processes of life activity. For example, metabolism in cells is based on specific reactions of exactly left-handed molecules, not their mirror antipodes. Thirdly, asymmetry is manifested in the very form of living organisms. In most animals, including humans, the heart and liver are located asymmetrically, and the organisms themselves have a certain twist. Thus, on Earth there was a unique macroscopic amplification of that microscopic symmetry violation, which took place at the dawn of the universe. Scientists are still searching for an explanation for this phenomenon. The world is a text written in the language of mathematics, Galileo Galilei. In fact, a combination of many factors led to the origin and development of life on our planet. Earth's fortunate location in the solar system, neither too close nor too far from the sun. This provided a suitable temperature regime for the origin of liquid water. The presence of liquid water and carbon dioxide, critical substances for the chemical reactions that led to the origin of organics. The presence of organic compounds on the early Earth, which may have been brought in by comets and meteorites. The energy of lightning discharges and ultraviolet radiation from the sun also contributed to the synthesis of organic molecules from inorganics. volcanic activity, which created gradients of temperatures, concentrations of substances, that is, a variety of conditions for chemical evolution. The presence of cycles of day and night, the change of seasons, periodic fluctuations of conditions also stimulated the complexity of systems. The presence of the Earth's magnetic field. It created a defense against harsh cosmic radiation that would destroy complex organic molecules. Tectonic activity that led to the formation of continents and oceans. The diversity of marine and terrestrial habitats stimulated the development of different life forms. Cyclical changes in Earth's climate. Glaciations and warming created significant evolutionary challenges for organisms to adapt. The emergence of photosynthesis, which dramatically changed the composition of the atmosphere, enriching it with oxygen. This paved the way for respiratory processes. The emergence of eukaryotic cells, a qualitative leap in the complexity of living systems. Symbiotic fusions of primitive organisms that gave rise to new forms. And finally, the ever-accelerating biological evolution through natural selection and adaptation to the changing environment. The presence of a sufficiently large natural satellite of the Earth, the Moon, can also be considered as a manifestation of symmetry breaking. The fact is that most planets of the solar system either have no satellites at all, or they are very small, like Phobos and Deimos of Mars. And the Moon is about 1/4 the diameter of the Earth itself, a rather unique ratio. Perhaps the Moon was formed when protoplanet Earth collided with another large celestial body. This cosmic clash of symmetries led to the asymmetric Earth-Moon system. So in the observable part of the universe, we have not yet identified any systems truly similar to ours with a large natural satellite. Earth and the Moon remain a rather unique duo for now. All things flow, all things change. Heraclitus. Variability and symmetry breaking is one of the foundations of the universe. The anthropic principle is one of the most mysterious and multifaceted concepts in cosmology, causing a lot of discussions in the scientific community. According to this principle, the fundamental parameters of the universe that we observe must allow for the existence of an observer, that is ourselves. There are several versions of the anthropic principle, ranging from weak to strong. The weak principle states that we can only observe a universe whose parameters allow for our existence. The strong one is that the universe is purposefully set up for the emergence of conscious life. The first version seems rather trivial and logical. If the conditions in the universe were incompatible with our existence, we could not observe it. However, the strong anthropic principle is much more controversial because it essentially gives human life the status of the purpose of existence of the entire universe. Proponents of the strong principle point out that many fundamental parameters of the universe are within a very narrow range of values compatible with the origin of life. For example, small deviations in the density of matter after the Big Bang would disrupt the formation of galaxies and stars. Critics, however, call this merely a manifestation of statistical self-selection. Conscious observers can only form in a universe with suitable conditions. But it does not follow that the universe was originally designed for the emergence of life. The anthropic principle also raises the question, is man something unique and special in the scale of the cosmos? Or is our universe just one of many, where the right conditions just happen to arise? This reveals rather difficult philosophical problems of our purpose in the world. Thus, the anthropic principle forces a new look at the question of our origin and place in the universe. And though there is no unambiguous answer to it yet, the very statement of this question is a huge stimulus for the development of cosmology and the study of the deep mysteries of our existence. It is impossible for man to foresee what path the evolution of mind will take on other planets in other solar systems. Lem. Solaris. On the one hand, man and all life on Earth do represent a unique phenomenon in the universe we observe. We are the messengers of the corner of the universe where the original symmetry was broken and complex forms of matter organization emerged. However, on the other hand, human capabilities to comprehend the deep laws of the universe and its colossal scale are still very limited. Our planet is only a grain of sand in the boundless cosmos, and mankind exists on it only a fraction of an instant in the cosmic timescale. Therefore, despite the uniqueness of life and mind, we can hardly consider ourselves a full-fledged representative of the universe. Rather, we are only a small but important part of the grandiose universe, the laws of which we have yet to comprehend. And this endless journey of discovery is the true purpose of man as a thinking particle of the universe. The intellects of the inhabitants of other planets may have far surpassed us, but that does not mean they are immortal. Clarke, 2001, A Space Odyssey. Suppose there are n independent factors necessary for life to arise on a planet like Earth. Let the probability of realization of each factor be p equals sign 0.5. Then, according to the total probability formula, the probability p that all the necessary factors are realized at the same time will be equal to p equals sign p circumflex n, where p is the probability of one factor, n is the number of factors. For example, at n equals sign 100, we get this number. This is an extremely small value. At n equals sign 1000. The probability will be even many orders of magnitude smaller. Thus, even with a moderate number of independent factors and a probability of 0.5 for each, the joint probability of realization tends to zero very quickly. This illustrates how unique and unlikely from the point of view of statistics is the very fact of existence of the planet Earth and life on it, under any realistic assumptions about the probabilities of individual necessary factors. There is a supreme point in the being of man, a supreme point in the being of mankind, a supreme point in the being of civilization. Strugatsky, Picnic on the Side of the Road. Human evolution is a long and multi-stage process, as a result of which the intelligent Homo sapiens evolved from primates. According to modern ideas, the evolutionary history of man has about 7 million years. The first primates separated from other mammals at the end of the Cretaceous period. About 25 million years ago, there were great apes, from which in the Miocene epoch branched off a line of hominids, higher primates, which includes man. The earliest representatives of hominids are considered Australopithecus, who lived 2 million years ago. They already had bipedal locomotion, but the brain volume was small. Then came the genus Homo with a larger brain. The most famous species is Homo erectus, which lived 1.9 to 140,000 years ago. About 200,000 years ago, Homo sapiens as such appeared. Gradually, he supplanted all other hominid species. Modern man has a developed brain, the ability to abstract thinking and speech. This has allowed him to develop a sophisticated culture and technology. However, many aspects of human evolution are still the subject of scientific debate. It remains unclear whether the evolutionary process was linear or whether there was interbreeding between different hominid species. The role of natural selection and other factors in shaping sapiens is also debated. In recent decades, controversial theories about the influence of extraterrestrial civilizations on human evolution have emerged. However, the Darwinian mechanism of natural selection and gradual evolution under the influence of the environment remains fundamental. Thus, despite the many unresolved questions, scientists continue to reconstruct step by step the story of human origins and development, one of the most amazing stories in biology. And as new data becomes available, this picture will be refined and enhanced. We Earthlings are the only intelligent life in this part of the universe, or at least the only one at this stage of its development. Lem Solaris.